Hi, and welcome to this short video on interactive debugging. So quickly, I'm just going to go over kind of the issue that interactive debugging will help you solve and what kind of the current state of play is before you use interactive debugging. So to start with, what you'll do is you'll have your code or you'll have someone else's code that you're running, and it will kind of look like this black box here. So you won't be able to kind of see what's going on under the hood, but what you will be able to do is call the code from the terminal with some kind of input potentially. So maybe you give it some strings, some integers, a couple file paths, say, some images, something like that. There may be an input that you require. So you have quite good understanding of what you're giving into the code. You don't know what's going on under the hood, like I mentioned, and then you get an output. This might be something you expect, so kind of follow this green line and you're like, oh yeah, that looks good, that's what I expected to happen. Or quite often the case with non-production ready code is you kind of follow this red path here, and it's kind of a case of, that's not quite right, or that's definitely wrong. And it's then going back to the drawing board, well, I've got this massive black box, where do I start? So interactive debugging can really help you with that. So as I mentioned here, there's kind of some issues with this just giving an input and just looking at the output kind of style or method to understand how the code is working and kind of give you confidence in the code that it's working as expected and give you the ability to quickly debug and improve the code. So it's hard to do by just giving inputs and just receiving outputs, like I mentioned. And it's also, even if you do get this green path and you think, okay, perfect, that's right, it's also quite hard or almost impossible to quickly confirm if your behavior is correct or if it's coincidental. So just because you give it, maybe we have a piece of code that adds 10 to a really simple example, it adds 10 to an input integer you give in. Just because it gives 20 out, well, yes, likely it is the case that your code is working correctly, but there may be something going on in the hood that's not expected or a behavior that's coincidentally making that happen that you don't want to happen. And that can be even more painful in the long term because it may go uncovered for several weeks or several months before you realize that that's happening, and it could cause other issues that you're not aware about. So understanding the kind of root cause and really understanding line by line your code is very beneficial to you moving forward when you're building in small teams or building larger projects. So this is a really useful thing to be able to do this interactive debugging. So I won't go over that, but the traditional approach is like what we already said, where potentially to build up confidence, what you would do is you would start adding or start testing lots of different inputs here. So you're given integers like our earlier example, well, you'll start putting in lots of different integers to make sure that this works. And maybe you'll put in a string to make sure that the unhappy path is, or the error is raised correctly, etc., etc. So that can become quite time consuming. And also, again, it does improve your confidence, but still, that there's still a chance that you could be coincidentally getting something out which is giving you confidence that isn't correct. Um, Another thing that I've seen a lot of times happening with the traditional approach is people then adding print statements into your code, and I'll show you that in a second, but kind of adding prints to kind of help you get confidence of what's going on through the code. The issue with this, I find anyway, is that you end up with loads of print statements all through your code, and sometimes they forget to be deleted, and it's quite time consuming. And as we'll see with interactive debugging, it's just completely unnecessary. You don't need to do that when using interactive debugging in VS Code. So the solution here is we use interactive debugging, and this is now the kind of the code box that we've got up here, but you can see now maybe we've started to uncover the methods that are in, the variables that are set, and this is all interactive, so it will update in live time. The values and types are all visible. So this is really helpful for us and really a real time saver that I found having kind of brought this into my repertoire over the last couple of years. Let's go now into an example. So what I've done here is I've just loaded up a VS Code window, and I've got this main.py, so this Python file, which has some very simple methods here. And then we've got set some variables down here, so from line 16 to 22, and then we are calling some of the methods that we've created earlier with some of the variables themselves. So if I'd say just been given this from a friend or a colleague or something like that, it would be maybe okay. This is very simple, so I could work this out quite straightforwardly, but you could imagine with quite a lot of more long-winded bits of code that this would be quite hard just to be given and just have an idea of what's going on. So potentially, to try and get my head around this to start with, what I might start doing is running this main.py file to get an idea of kind of what we're trying to do. So if I run python main.py, so I'm now just running this main.py file. I'm in my new project, which is in the folder, so we're all very good to run here. I run that, so we get nothing, which makes sense when you look at it because we don't have anything printed out to the terminal or anything like that. So when we run this, we wouldn't expect to see anything. So what I might be inclined to do now is start to add some prints that we mentioned earlier. So some temporary prints just to kind of get a flavor of what's going on. So I might think, well, I might print this example one. So we know that convert to string returns some kind of value, which is then assigned to example one. So I might print example one. We also know that convert to string is converting a string to an integer. So we might also do print the type of example one, so we can get an idea. And this will print to the terminal, the window here. So okay, nice. So we know that we get 15, and that 15 is type int. So that's what we would expect to happen. So we kind of are getting some confidence in this code, and we kind of understand what's going. So what's happening is we're calling this method with e, and e is the string 15. We have then printed the example one, which is the return value of this method. That's 15, and we printed the type of that example one, which is integer. So that all makes sense, but this is quite long-winded, and you can imagine, like I said before, if you've got hundreds of lines of code over multiple files within multiple folders, that adding in these prints and trying to get your head around what's going on would be quite confusing potentially, and potentially lead to mistakes, and kind of just generally it would be quite messy, and I wouldn't say it's great practice, because you might end up leaving some prints in, and it's just kind of not a good, efficient use of time. So what we can do instead is we can do interactive debugging. So how do we do interactive debugging? So it's really simple. So the first step we need to do, so I'm in VS Code here, I've deleted my print statements. So if we rerun this, we'll get nothing printed here, which is perfect. Interactive debugging, we're going to go across here. So we're going to go across the play sign with the bug on the bottom left-hand corner of the play sign. We need to create a launch.json file. So once I've clicked that, I can do create launch.json file. So if I just click here, and then I'm going to click Python file, and then this sets up a launch.json file. So what's really good about this is it gives you a template that you can already use kind of out of the box. So the one thing that I would recommend doing here is just changing the name. So this is going to be the name of your debug session, which we can see here. So I'm going to call this my debug session here. So that's the name there. Types Python, request launch program, the file, console, integrated terminal. All of this is fine. So we can leave all of the other parameters the same as they are. All these values are perfectly fine. So I can then close this. And what I can do is I can now see that my debug session is up here. That's perfect. That's exactly what we wanted to do. And now we can start playing with the interactive debugging window. So the one thing before we start using this is we need to add in a breakpoint. If we don't add in a breakpoint, the debug session won't know where to stop within our code and then allow us to walk through. So it will end up going through the whole code, and it will be very similar to when we ran Python main.py in the window, in the terminal here itself. So I know that I am just these methods are just being set up here, so we don't want to add our debug window in here. I'm going to set it where we set the first variable, so on line 17. Now we add this breakpoint in by just clicking to the left of the line numbers on the left here. So if I click it again, it will remove it. And if I go over there, just a single click, and I add that breakpoint in. Perfect. As a tip, you can also add multiple breakpoints in if you want. And you'll see when you become more confident with interactive debugging that this is potentially useful to allow you to speed up how you skip through the code. But for this very simple piece of code, we're just going to add one breakpoint there in line 17. So now, perfect, I'm all ready to go. So what I'm going to do is I'm going to go up to my top left here, and I'm going to go start debugging. As you can see in the brackets, you can also use the F5 shortcut. But just so you can see with my cursor and track my cursor in this video, I'm going to use my cursor, but F5 also works. So perfect, you can see I get this little bar up here, which allows me to navigate through my code. So that's really useful, and we'll come on to that in a sec. So nice. So what you can see now is we've run this code, and in my debug session, we have gone through main.py, and we've gone through lines 1 to 16, and then on 17, we've hit the breakpoint, and the debugging session has stopped and allowed us to it will now allow us to go through line by line and see what is going on within this code, which is really helpful. So 2 points to pick out here. Firstly, we can see over here on the left hand side, this is really useful So this shows us all the variables that have been set and everything that's kind of going on and what's going on in our code line by line. So you'll see this start updating as we go through the lines. But for now, you can see everything's empty because nothing's been set in variables at the moment. No, there's no local variables and no global variables. But this will start updating as we flick through. The second bit that's really important to get your head around is this over here. This is kind of your navigation pane, and it allows you to step through, step over, step into code, and it also allows you to restart the session. So this would be going back from the start again, and then it also allows you to stop the session completely. So what I'm going to do is I'm going to step over. So step over and step into, we'll go into a little bit more detail in a second, but for this now, it won't matter if you go step into or step over because there is nothing to step into. So if I step over line 17, I'll go to line 18. Now you can see on the left-hand side here, we've now can see that A has been set to milk. So this is perfect, and this gives us a really clear, granular picture of what's going on. So we have one variable set at the moment, which is A, and it's set to the string milk. If I then step over again, and again, and again, and again, one more time. So this is all the variables that I've set. These are quite random variables, but you can imagine in a larger project that this could be, there could be more variables being set, and they almost certainly will have more meaning than these ones here. So if I come back over here to this variables, you can see the local variables that have been set now. So I've got milk is set to A, like we just looked at before. We've got B set to cheese. We've got C set to true. We've got D set to this dictionary here with some key and values. And we've got E set to the string 15. So this is really helpful, and this allows us to keep track of what we are looking at. So the one other thing just to add, which is sometimes really helpful, I don't use it loads, but it can be really helpful, is we have this watch bar here. So say we know we wanted to keep an eye on the variable B, what we can do is we can add to the variable here, and it says express into watch. So we can put anything in here, but let's just put B. And you can see that B is set to cheese. So this is exactly the same here, but what you'll find in practice is this can become quite cluttered. This variables, these local and global variables, especially in more production heavy code, where there's a lot of things going on. So having this little shortlisted watch list here can be really helpful, and it will allow you to keep track on maybe your most important variables or on a variable that you're kind of keen to keep a track on. So that's a really cool little feature there, and we can add multiple things here. So we could also add, say, D if we want to keep an eye on that. And then that will just keep the those two kind of shortlisted, I suppose, what you say. Some other bits in here as well, as you can see things like, so for this dictionary, we also get some kind of more functionality here. So we can see like the length of the dictionary, for example, at the moment is 2. Again, this will always update as you go line by line if they are updated. Otherwise, they will stay the same. It's completely interactive and kind of up to date as you step through. Okay, perfect. So now we're on to line 25. So we're looking at this convert to string method that's being called, and it's being called with E that we know is currently set to 15. So this is really useful in code to kind of keep an eye. So we can see that E is 15 at the moment. So it's being called with E15, and we know that the convert to string method is going to return a string, is going to return an integer of a string that we give the method. And that's going to be set to example 1. So let's step into. And stepping it into then means we'll go into that method. If we stepped over, it would just go to line 26, and we would see the updated variables here. So we've stepped into this, and we can see that we go down. You can see that the variables have now been removed here because we're now within this method itself. So there are no local variables set within this method besides the string 15. We can see that we've also then got this additional conversion boolean equal to true. So we can see that this has been set now, which is really useful. And if we step into this again, we'll return back. And now you can see we're back to where we were before on line 25. So you can see all of the local variables that were set before are all there. You can see that no longer is the case that conversion boolean is true is set, because that's no longer a local variable. That was only a variable within the method. So that's really useful as well to understand where variables kind of persist and where they don't persist. It gives you a good idea. And I'm going to step over one more time. So we've gone to example 2. So you can see that example 1 is completely finished now. We can see that example 1 is being returned as 15, which is really useful. And we can also see that everything else has stayed as it is. So one bit to say here is maybe we want to make sure that this was an integer. Obviously, it's quite clear it's an integer, it's not in a string anymore, etc., etc. But we can go to the debug console here, and we can actually use this interactively. So what I could say is I could do type. So I could find the type of example 1, example1. And we can see it's the class integer. So you can see how this is really useful in terms of allowing us to probe further down into our code, and we haven't had to add any of those temporary print statements in, we haven't had to add anything like that. So this is a really quick way to do this. Perfect, so that was just a quick bit there. So I'll stay in the debug console for now, and I'm going to step into, so in here, I think it's F11, yeah, it's F11, step into line 28. So that's going to take us to the method in line 5. Perfect, so we're in here now. You can see again, the variables have reset because we're now in this method, so there's no local variables set there. I'm going to step into this. You see we've got the addition key, so we have added 10. This is just a random string for this simple example, but you can imagine this could be more complicated. Moving on. Within this method, what I've done is I've also added another method. So this is kind of a nested method within a method. And again, this is a really helpful thing to understand what the code's actually doing line by line. So if I step into this again, we will then jump into the list generator method, which is on line 10. Perfect. And we can see that we've got no variable set again, because we're now within this method where there are no local variable set, and there's no global variable set. I don't set any global variables here at all. So if I step into this, you can now see, okay, X has been set to 1 in this list generator method, Y has been set to 2 as a string, and Z has been set to this Boolean false. Again, at any point here, I can go into the debug console and I can go, what is the type of Z here? Oh, it's a Boolean, that's perfect. And what is Z? So you can do Z is false, perfect. So you can see the variables here, which I normally prefer to do. You could watch any shortlisted variables that you want to see here, which is useful. And also over here in the debug console, you have this interactive element where you can kind of quiz what's going on in your code, which is really useful. And this becomes more useful when you get more complicated code kind of going on. So this is a really cool feature to be aware of. Okay, perfect. So I'm going to step into this again, and we get back to list generator here. So even though I'm stepping into this, but I return back because I've finished this method. So I've stepped into list generator, I've gone through all of list generator, and I've got back to here. This code doesn't make too much sense because it's returned something that's then not being stored, but for the purpose of this demonstration, doesn't matter too much. I suppose ideally this would actually have set like something like X equals list generator or some variable equals list generator to save that. But here we're not really saving it, that returned list. So you can see over here what was returned. So also in brackets it says it was returned, which is really useful when it shows you what was returned. I'm then going to step down and then step down again, and you can see, okay, perfect. So we've gone through all of this example 2 add 10 method, and we've gone through line by line to see exactly what's going on. So let's see over here. So we have A is still set to milk because before nothing's changed. We've not updated that anywhere. That's really useful. We can see that we've got this returned add 10, and add 10 is 25, which is really useful. So we can see what that method returned itself. We can also see that example 2 when we stepped over again. So you won't be able to see it here because this is the last line. If we had an extra line here, which was something like X equals, we're updating X so that instead of milk, it's now milky, say, which is very imaginative, I know. If we reran this, we'd then be able to see example 2. So if I stop this here, so at the end of your debug, if I just step over again, it will finish. So that's perfect. So once you've finished your debug, everything goes here. So that's just something to be aware of. I've just added milky in here so we can see what example 2 returns. So if I go, I've put a breakpoint right at the end. So this means that our code will run all the way through without stopping, and it will stop right at the end. So we'll be able to get back to the place we were just a second ago. So we'll just give that a second to run. Perfect, it's just loading now. Okay, perfect. So we've got right to the end here. So this is where we were just 30 seconds ago. I've just added this extra line in so we could see what example 2 returned. So you can see that example 2 is this number 25, which is what we expect. But again, like I mentioned, with more complicated code, it's really cool to get this granular level. We could go to the debug console here and we could quiz that. So we could say, well, what is example 2 here? Okay, it's 25. And the type, what is the type of example 2? Okay, perfect. It's a type integer. That's really useful. And even in here, what we can do is we can do some simple bits like we can add example 2 and example 1 together. Okay, perfect. That's 40. So you can see how there's some interactive element there, which is really useful. The one thing to note, like I mentioned before, and like you just saw, was once you've run through the whole code, all of this interactive debug console, the variables over here will be kind of forgotten. So they won't stay there, they won't persist. So if I just step over, so we're on the last line, step over and kind of finish that, you can see that all these variables have now gone. And you can see here we get this helpful message which says, please start a debug session to evaluate expressions. So if I type in, I can't even type in, but there's nothing that I can do there now in that debug console. Perfect. So that's kind of the end of what I wanted to show you and how interactive debugging sessions work. I hope that really helps your understanding, and I hope that helps you in your debugging endeavors to be more accurate and kind of avoid you wasting time trying to debug with more traditional methods. Using this interactive debug part of VS Code allows you to kind of really probe into exactly what's going in line by line and allow you to quiz the code line by line, which personally I find really helpful and means that it saves me a lot of time in the long run. So feel free to like this if you found this useful, and feel free to drop a comment on anything else you'd like to see me kind of discuss and go through to help you with your needs when it comes to coding. Thank you, and I'll see you soon with some more tips and tricks. Bye bye.